Hey everybody, we're here with Synadia over at the Rancher booth showing off how NATS and Rancher actually can work together to make distributed systems made easy. In regards to that, we actually, that's me, Delaney. What we did is we actually made a fun game. This year at Kubernetes, or KubeCon, they made a basketball theme, and we said, hey, how can we show off how Rancher Government Services works and Synadia? And we said, let's make a game where you actually can shoot down drones, but in this case, they're basket drones. So what it actually is a interactive way to show tactical edge. Instead of just showing off a couple of sensors, we're actually using your mobile phones as input devices where we grab the data in a live way. The basics are just like a normal application. However, in this case, what we're doing is taking the normal web app, grabbing all the data, and putting it directly into NATS. So all of the streams that you get from WebSockets and a KB store, all that goes directly into NATS. And some of the leaderboard is done with SQLite, but otherwise, this entire thing is stored directly on NATS. When it comes to being born on the edge, the cool thing is all of these parts are built directly in. We don't have to run separate binaries and run separate servers to get all of these different features. So everybody, all these different services, the game server, the leaderboard, the matches, all connect directly to NATS. So it doesn't matter about DNS or NATS punch through or all these things that you normally have to deal with from point-to-point services. What we're doing is actually having all the services talk directly to NATS, no matter what language they're written in, and have direct control of that messaging. So if we go a little bit deeper, you can see that every one of the clients is actually talking directly to one of these clusters, but they don't have to know the details of this. It gets load balanced properly for them, and each one ends up being a separate deployment. If you go over to the RGS side, you'll see that they actually have a on-premises air-gapped solution that's running all this in a small form factor, which is pretty nice. And if you see, we're running NATS, but we're also able to run the entire Natcher, RKU, Longhorn, and NuVector all at the same time on minimal hardware. A little bit into the game, what we're doing is using your device's gyroscope and orientation sensors, throwing that into a web database, and then pulling out key value stores and match streams on the fly and watching that data. So instead of waiting around and having to do constant polling, NATS has built in the ability to do KV watching, which allows you to really reduce the amount of work you have to do updates. So the leaderboard uses server-sent events on the website, but all it has to do from the rest of the stack's point of view is watch for keys and pull them down and gets that within a few milliseconds, which is great. Also, internally, it's using SQLite to do projections to get the current daily scores, because we're actually giving away drones each day. And then when you go and look at a match, you're looking at hundreds of thousands to a million events per match. And instead of grabbing that to one piece at a time, we're actually saving that off into the object store to make that even a faster cache. So the object store, the key value store, all of this stuff is directly built on top of NATS in a durable queue. So only one place to secure for your entire networking stack. So if we go a little bit deeper into what NATS does and how it makes all this work, really what NATS is the best thing about it is that it makes application communication easier. It doesn't matter what language you're using or what stack you're using. You could be in Kubernetes, you can be outside of Kubernetes, you could be even on your local embedded server and run NATS. It makes everything work really well. And instead of thinking point to point, you're thinking in terms of subjects, and then multiple people can connect to those subjects at any time. When you're talking about the places where NATS works out really well, is that it can actually change your paradigm for how you're building distributed applications. So a lot of times people think about NATS as a messaging framework, but I think of it as a distributed framework, which means that you can create clients that can be interconnected in a way that's just really hard to do if you're using Redis or Kafka or all these desperate tools. You have one place that connects all these things, which means that it's much faster to develop. In fact, the entire basketball drone demo was done in about a 2.5 week period with one developer. So what's also nice is that because NATS does not care about the internals of your message, it doesn't matter whether you're using JSON or protobuf or you're writing it in Go, Rust, C++. It doesn't matter. We have clients for every different language so that you can have a single way to interact with each other no matter what languages and what frameworks you're using, whether front end or back end. So the other thing is, like I said, not point to point. So you're thinking in terms of subject. So it doesn't matter if the subject is a single server that's running or if all of a sudden you just decide to load balance it with 1,000 machines. We handle all that stuff for you automatically. So there's location transparency. We handle things directly with service pipes. You don't have to think about TCP. Other than connecting directly to the NAT server, you don't have to think about any other services coming on or offline. You just connect directly to NATS. It does also make it a lot easier that you don't have to do, ironically, NATS punch through, even though that's a different technology. NATS allows you to get directly access, whether you're talking locally or in a Kubernetes cluster. You also have to know almost nothing about DNS other than being able to connect to a single NAT server, and then it can figure out the rest of the topology on the fly, which is pretty great. And what's great is it doesn't matter if you're talking about a single embedded server all the way out to giant superclusters, your code stays exactly the same. So in the general case, if you're just talking about normal core NATS, the kinds of things you normally use for public PubSub, it's very simple. You just publish to a subject and then you subscribe to a subject. There's also things like what's called the JS sub is actually a Jetstream subject, which is a durable queue that allows you to pull that data off at your rate. So you can have different clients that can pull down that data at different rates, which is really handy. So most of the time you want to use core NATS to get millions of messages a second, even on a laptop. And then when you need durable connections, then you can start using the streams. From there, we can get into details about how we did the basket drone. But the cool thing is, even on this conference Wi-Fi, we're talking over 100,000 events per match, and we can handle thousands of users at the same time. So that's literally, I did the math, and it works out to about 150 million messages per user if they played all day. So if you guys have any more questions, please let us know. Otherwise, have a great conference.